Hello, my name is Bruno Oliveira and welcome to our third episode in the Play Games and NDK series. We're going to talk about some threading and lifecycle issues that may be tricky. So first of all, let's start with threading. So when you are using Play Games and NDK, what you have to realize all the time is that the UI thread is different from your game thread. So whenever you're writing your game logic, that's going to be running on the game thread on the native side. And whenever you do most of the calls of the Play Games API, you're going to want to do them from the UI thread on the Java side. So usually one of the patterns that you can use to manage that difficulty is just create methods called post something something, and then those methods post to the UI thread, and then on the UI thread you actually use the game helper to make the corresponding API call. So something like this, post submit score, which we covered on the last video. You just call that from the native side, and then that posts to the UI thread. How do you call this from the native side? Well, you can just use JNI. But now, how do you actually do the opposite? How do you call from Dalvik to native? When you call from Dalvik to native, all you have to do is declare a native method in your class, and then implement the corresponding native method. So, for instance, here we are reporting that the sign-in has succeeded into the native code. When you write that native method, one thing that you have to look out for is that you're actually running on the UI thread. Even though you've crossed the native barrier into native code, that doesn't mean that you're running on the game thread. You're actually running on the UI thread, and if you start trying to manipulate your game objects and game logic there, you might run into very hard to debug issues. So one of the things you can do is just synchronize at that point. However, synchronization may be expensive. Like if you have a mutex or a semaphore and so on, and you're going to lock that on every frame that your game is going to draw, you might end up with a very slow game. So one of the very useful patterns we usually see is you want to do an atomic write, especially when it's a very small data structure that you just want to like pass a boolean between threads. You can do just an atomic write. So in this case, we are using the system.atomics.h. So this is these are a few convenience functions that allow you to do atomic writes and reads. In this case, we are getting the new state from the UI thread and then writing it atomically to that static variable called state. Because this means that when you try to read it from your game thread, you can just read it, because this can be called from any thread. You can just read it, because and since the writing is atomic, you don't have to worry about race conditions there. So you get the state based on that. So this means you can actually get the state on every frame. So you don't have to have a callback saying, yes, sign-in has succeeded or failed on the native side. Because in any event, you're going to have to process every frame to do animations and such. So you're already occupying the CPU on every frame. So it doesn't really cost much more just to read a Boolean variable to see if the user is signed in or not. So you can eliminate some complications there that way. So you can call get sign-in state on every frame without having to write callbacks or anything. So let's talk about the life cycle of a Play Games app. So back in the good old days, I remember that writing a game was pretty easy because there was no life cycle. Essentially, the game gets started, the game gets played, and then the user stops the game and then goes back to the operating system. So that was a pretty easy time. Now, with modern operating systems, especially on mobile devices, you have a whole bunch of callbacks that you have to pay attention to. So when your game starts, you get on create, then you get on start, then you get on resume, and then you get the window focus, and then you get on pause, and then you lose the window focus because of the lock screen, and then you get on stop because the user has gone back to the home screen, and then you get on start again. So it's a whole bunch of callbacks. Some of them are hierarchical, some of them are not, some of them come out of phase. And you have to pay attention to all of those callbacks to know when you can and when you cannot render stuff into your game. Because sometimes you may even have a GL surface, sometimes you don't have a GL surface, sometimes you should not be running, sometimes you should deallocate stuff. So you have to pay attention to all of those callbacks. So it's important to keep track in your native game of where in the life cycle you are regarding those callbacks. So you have to know whether or not you are between on resume and on pause. You have to know whether or not you have the window focus. You have to know whether or not you have a surface or you don't have a surface, and so on and so forth. And now we're going to talk about how to integrate Play Games into that flow, because it's very important as well, if you're using Play Games, to know when you can make Play Games API calls and when you cannot. So let's try to simplify this lifecycle a little bit. It's not as scary as it looks. So normally, this is the basic Android activity lifecycle. You get on create, you get on start, and then you get on resume and on pause. These events are all nested within each other. So you're always going to get on resume only after on start, and then before you get on stop, you're going to get on pause. So you can have a variable that tracks where in that state machine you are. And then, of course, your game should only be actively playing between on resume and on start. And then, of course, there is an out of phase sort of like state machine which is the window focus. So window focus can come in and come out even if it's out of phase with the other events. So you should not assume that that's going to happen between on resume and on pause, but you should assume that that may happen out of phase with that. So you have to keep track of when you have the window focus. Other than that, if you're using OpenGL, and you most likely are if you're using NDK, you also have to keep track of when the surface gets created, gets resized, and gets destroyed. So that's one more piece, one more moving piece that you have to keep track of. So it's only when you have those 5 things that you can actually do active gameplay. So you have a surface, you have focus, and the activity is in its resumed state. So how does the Play Games API merge into this? So this is where you have the gameplay, right? So how do you deal with the Play Games API lifecycle on top of that? So fortunately, the Play Games lifecycle is actually nested in the activities lifecycle. So it's not actually as difficult as you might imagine. So we have on start and on stop. So between on start and on stop, that's when the Play Games activity lifecycle actually happens. Typically after on start, so there is no way to keep a connection to Play Games while your application is not started. So whenever you get on stop, you actually lose the connection to Play Games and you have to restore it on start. If you're using Game Helper or base game activity, that restoration is done for you automatically. So you don't have to worry about that, but you have to know that it exists. So whenever you get the on start callback, you're not connected to Play Games. And then you have to wait for the on sign-in succeeded or on sign-in failed callback. So there is this window of time between on start and on sign-in succeeded where your activity is started. It may even be resumed or have window focus. You may even have the GL service, but you might not be connected to Play Games because you're waiting for the on sign-in succeeded or sign-in failed callbacks to be called. Only after that point are you actually connected to Play Games and you can make API calls. And remember that when you get on stop, you get disconnected from Play Games. So this is what the lifecycle looks like. So just simplifying this a little bit. So what happens, what may go wrong in this case? So suppose that your game is actually running and then before you get the on sign-in succeeded callback, you try to unlock something. The user achieves something very extraordinary and you want to unlock it, then you might run into trouble because at that point in the life cycle, the Play Games API is not accepting API calls. So you're gonna probably, if you haven't thought about that, you're going to get a crash. And if you have thought about that and you're protecting it with an is-connected test, what's going to happen is that that achievement is going to be lost. So nobody wants that. So one of the strategies that some games use is that when you are between on start and on sign-in succeeded, you show a please wait screen. This is usually not so bad because the interval of time between on start and on sign-in succeeded is usually small. If the user has already signed in before, it's going to be pretty small. If the user has never signed in before, it's also going to be pretty small because it's going to fail quickly. So it's going to be it's not going to be typical for that to take more than say one or 2 seconds. So it's probably a good idea to put a please wait screen between on start and on sign-in succeeded, or of course just handle that within the logic of your game. So for instance, if every level starts with this intro screen that's going to last 5 seconds, then you don't need to put up a wait screen because you know that sign-in succeeded is going to happen before that pop-up. Before that storyboard scene goes away. But it's nice to check for that anyway. Once that please wait screen goes away, you know that you can safely do API calls. So that's when you try to unlock something. So this is one of the very useful patterns in that sense. So actually, the actual implementation is of course up to your game. You can do something very smart, or you can do something much more simplistic, just like putting a please wait screen. But the important thing is to notice that you have this life cycle issue, and you should be attentive in order not to make any API calls when you shouldn't. And I guess that's pretty much all there is to the life cycle. Thank you very much for watching, and we hope you make great games.